Hello class, welcome back to another section of our intensive calculus course. In this class, we're going to tackle limits of functions as we've been tackling, but under it, we're going to do determinate limit forms as well as indeterminate limit forms. Kindly watch the video to the end so that you don't miss any part of the video. Don't forget to like, subscribe and share. It's saying when you talk about determinate and indeterminate forms of limits, we are talking about limits as we approach infinity. Yes, infinity. We have certain functions which has or which is infinite. So if you want to find the limits as it approaches infinity, whether they're positive or negative infinity, how do you go about that? That is exactly what you're going to do in this class. To begin with, we're going to start with the determinate forms. When you say determinate forms, determined, meaning we can determine the limit, yes, meaning it's possible, determinate forms. Under the determinate forms, I have some expressions here. It is saying that p plus or minus infinity is giving us what? Plus or minus infinity. What that means is that if you have any number, say 2, say 3, plus infinity, our answer is infinity. If you have any number, say 2000 minus infinity, our answer is going to be minus infinity, because the negative infinity here is too huge for this 2000 to neutralize. That is the first determinate form. So wherever you see any number adding, subtracting from infinity, you know how to do that. The second one is saying that if you have positive infinity being added to positive infinity, our resulting solution is positive infinity. So that one is understandable. Whenever you are dealing with infinity and you add any two positive infinities, your resulting solution should be positive infinity. And the third one is saying that negative infinity plus negative infinity will also give us negative infinity. So if you have negative infinity minus infinity, the solution is going to be negative infinity. Here we don't do minus 2 infinity, no. Infinity is a huge and imaginary number, so that we don't know the exact value. So we assume it to be so big, yes. Then we have any constant multiplying plus or minus infinity will give us infinity. If I give you 40 times positive infinity, our solution is going to be infinity, positive infinity. Likewise, if I give you negative 2 times infinity, positive infinity, our solution will be negative infinity. This negative will affect the infinity. Then if I give you, let's say, 3 multiplying negative infinity, my solution will be negative infinity. So this is a determinate form. These are some of the infinity problems you can find, or we can determine the solution. Then finally, if you have any number over positive or negative infinity, our solution is simply 0. So if I have 4 over positive infinity, know that my answer is 0. If I have 2 over negative infinity, my answer is 0. So we are done with the determinate forms or the various forms. So I assume now you'll be able to solve infinity problems which has the determinate forms. Now let's take an example in the limit form so that you know how we do that. In this course, we are centered on limits, not manipulating infinities this way. So I'm going to take one problem so that we solve for the determinate forms. Now I'm going to give you the problem 1. We have limits of negative 2x plus 3 as x approaches positive infinity. In the previous limits class, I made mention that limit is simply you putting what you have here in here. But in the case of stepwise and piecewise functions in our last class, that was when it differed. So here, we are only to put this infinity here. And you should make sure that we get a valid limit as a solution. If not, it doesn't exist, or else you get indeterminate form. So let's see. This is simply from the properties, is simply negative 2 out limit of x as x approaches positive infinity plus limit of 3 as x approaches positive infinity. This is from the properties in our first class. So you realize that the limit of any constant as we are approaching infinity or as we are approaching anything will give us a constant back again. So here our solution is 3. When you come here, you're going to get negative 2, open bracket. Wherever you see x, you put infinity, so positive infinity. And you realize that this negative 2 multiplying out positive infinity. Then from the determinate forms, it is simply going to give us negative infinity, not 2, or you only add negative to the infinity. So negative infinity plus 3. And if you have negative infinity plus 3, our solution is going to be negative infinity. So this is a determinate form example, and this is how we solve determinate limit forms. Let me give you a second example of determinate form. So a second example is saying that limits as x approaches plus or minus infinity of 4 over negative 2x plus 3. When you have this is a rational function, and as usual, you just put what you have here, and this will be simply equal to 4 over the expression negative 2 plus or minus infinity plus 3. I extend here. Now, from our rule, we're saying that any number over positive or negative infinity will give us 0. So this is going to be 4 over negative infinity, which is 0, or something like that. Let's take our third example. Our third example is going to be an indeterminate form. So let's wait and let me explain the indeterminate form before we proceed. When you say indeterminate forms of limits, this is simply limits in which we can't determine the value or the resulting solution, or no limits, or indeterminate forms basically is any expression which we can't determine the solution. Yeah, let me say that way. Example is what you have here. If you have positive infinity minus negative infinity, what are you going to say? Will you say it is 0? Now, infinity here is not a specific value. I can give you one infinity to be maybe 1 billion, and I'll give you other to be 1 trillion. So if you tell me 1 billion minus 1 trillion, it will give you a number. And it can also happen that they are all equal. So it is indeterminate. You can't determine infinity minus infinity. Let's say positive infinity plus negative infinity. We call it indeterminate. Now, the second part is infinity over 0. Any number of 0 is what? Is 0. Any number over 0, as you know, is 0. But what about infinity? Infinity is a very huge number, a very, very huge number, which we don't know the value. So we say that it is not determinate. You can't determine it. You can't determine it. Then also, we also have something like any number over 0 is infinity. So these are the confusions or the controversies which makes it indeterminate. Then finally, 0 times infinity. 0 times infinity. Can 0 nullify a whole infinity? Something which we assume to be so huge that we can't specify? No. So therefore, 0 times infinity is not determinable, so it's indeterminate. Then infinity over infinity. If you have infinity out of infinity, will it cancel out to give you 1? No. And you already know that any number over infinity is 0. Why is it not being 0? So there is a confusion here, hence you can't determine it. Then finally, 0 over 0. You know you should have cancelled out to give us 1. But you know the number over 0 is also infinity. Then 0 over any number is 0. So all these stuff makes it indeterminate. Let's go straight to solve a problem so that you know how we use this in solving limits. So taking my third example, I'm going to have limits as s approaches 1 of x squared minus 3x plus 2 all over x minus 1. This is the function, and if I want to take the limit as approaches 1, as I said, I'm going to put 1 into it, and this will give me 1 minus 3 plus 2 over 1 minus 1. And this is going to give me 0 over 0. Now you can see that 0 over 0 is what? Indeterminate. You can't determine it. Hence, we have to rearrange stuff. We have to solve this in a way that we will get a proper limit, which is determinate. What do we do for that? We know that this is a quadratic function which we can expand. So we can get factors like x minus 1. Then, let's see, what will be the factors? If I multiply 1 by 2, factors of 2, that will give us negative 3, is going to be negative 1, negative 2. So negative 1, negative 2 will give me negative 3. So therefore, when I split, I'm going to get something like x minus 1, x minus 2, all over x minus 1, like this. So when I get this, you know that this will simply cancel this. Then finally, I'll put my 1 minus 1, that is 1 minus 2, sorry, give me negative 1. So whenever you get an indeterminate as an answer, you don't end there. You make sure you restructure your function, you get a determinate value. Now the fourth example, as I have limits as x approaches 1 of the function square root of negative x plus 5 minus 2 all over x squared plus 4x minus 5, like that. So once I have that, simply if I put 1 in it, I'm going to get root of 2, root of 4 minus 2 over 0. This also gives me 0 over 0. Yes, this also indeterminate. What do we do? We make sure we modify this and we do away with this indeterminate. In the modification, as I said in our earlier videos, we are going to find the conjugate. You multiply this expression, square root negative x plus 5 minus 2 all over x squared plus 4x minus 5, multiplying square root negative x plus 5, then plus 2 instead of the minus 2 here, and that is going to give me all over the square root, the same thing, plus 5, then plus 2. Once I do this, I'm good to go. So let's see what I have. So when I multiply the top one, I'm going to get something like negative x plus 5. Then you realize that this and this will cancel out. So I'm going to get this difference of 2 squared. So this all squared minus this all squared. So that is going to give me minus 4. You take your time, then you expand. So negative x plus 5 all over 4. Then all over the expression, I'm going to multiply this whole thing by this. So I'm simply going to have x squared plus 4x minus 5, multiplying the expression, the square root of negative x plus 5 plus 2, like this. And what is this thing giving me? I'm getting 1 minus x all over x squared plus 4x minus 5, multiplying the square root of negative x plus 5 plus 2. So once you have this, let's see. If I'm to put 1, will I still get 0? Yes, I'll get 0. So we need to eliminate something here so that we get a positive something. So from here, how can I expand this? I know that I have 5, negative 5. So if I have negative 5, the factors are going to be positive 5, the negative 1 as my factors. Positive 5 and negative 1. So that is going to give me positive 5 and negative 1. Upon simplification, I'm going to get something like 1 minus x. Then, so let's see from here, subtract 9. So all over here is going to be x negative 1, then x, so negative 1, then 5, yes, positive 5. So x plus 5, then x minus 1, like this. So how do I get x minus 1? I simply this all over root of negative s plus 5 then plus 2. Sorry. So once I get this, I'm good to go. I know that when I take negative up, this is going to change to x minus 1. So I'm going to have something like negative 1 x minus 1 all over the expression s plus 5 x minus 1, then square root of x negative x plus 5 then plus 2. At this point, this will cancel this. I have negative 1, I have this. Wherever I see x, I'm going to, x plus 5. This will cancel this rather, so I'll have my x plus 5 there. So now at this point, wherever I see, I put negative 1 over x plus 5, then multiplying the square root of negative s plus 5, then plus 2. At this point, wherever I see x, I put 1 there. So this will give me 1 over 1 plus 5 is 6. Multiplying the expression, negative 1 plus 5, this will give me 2 plus 2, 4. So 6 times 4 give me 24. So the answer is 1 out of 24. You see how the indeterminate forms cause messy works? So once you get indeterminate, you make sure you modify and you get your determinate form. So let's see another example. So let's see. I also have another example. Example 5, which looks simpler, and that is exactly limits as x approaches plus or minus negative 3x to the power 4 plus 3x plus 1. With this example, as x approaches infinity, wherever I see x I'm putting infinity, I'm going to get negative 3 plus or minus infinity. So it's only plus, yes, it's only plus infinity to the power 4 plus 3 plus infinity then plus 1. Okay, so I'm going to get negative infinity here, then here I'm going to get positive infinity plus everything will be positive infinity. And you already know that you can't add negative infinity and positive infinity. That is indeterminate. So what do? I need to break this one down or modify it in a way that I will get a determinate value. So what do? What you do is you factorize this x4 out. So I get negative, x to the power 4, open bracket, negative 3 plus 3 over x to the power negative 3, then plus 1 over x to the power negative 4. Then you find the limit as this approaches infinity. You know that when I put infinity here, so negative 3 plus 3 over infinity to the power negative 3 plus 1 over infinity to the power negative 4, everything here and here will give me 0. So therefore, I'll end up getting negative 3 x to the power 4 as this. Then here I'll put my infinity sign, simply negative 3, then positive infinity, and this will give me negative infinity as my solution. So initially I was getting negative infinity and positive, which is indeterminate. Then afterwards you factorize this out so that you'll be getting these fractions. So once you get this, when you put the infinity sign, it will all be 0, then to be left with this alone. Then you solve that. So I have another example. Then you have to take notes. If you find the limit as s approaches infinity, whether positive or negative, of any trig function, it doesn't exist. Take note. The limit as s approaches infinity of cos x sin x tan x doesn't exist. Take note. Then let's see if I can solve another example, number 6. Then you realize I have limits as x approaches negative infinity of negative 2x plus 1 all over 3x squared minus 2. So here, when I put the negative infinity up there, I'm going to get positive infinity. So negative 2, negative infinity plus 1 all over 3 negative infinity all squared minus 2. So the resulting solution will be positive infinity all over positive infinity, and that is also indeterminate. Infinity over infinity is indeterminate. So what do we do? Here you divide through by the highest power. You divide through by the highest power so that you get negative 2 over x plus 1 over x squared all over 3, yes, over, so it will cancel, so all over 3, then minus 2 over x squared. And here, every fraction with x, when I put the infinity sign, there will be 0. This, so my answer will simply be 1 over 3. So this is the end of our determinate and indeterminate limit forms class. Thanks for joining this class. If you have any talent, drop it in the comment section. Don't forget to like and subscribe.